Hello again. My name is Bill Feinberg. This is going to be episode 6 of LeetReel, which is where I film myself solving coding challenges from LeetCode. Who knows, maybe in the future I'll move into other sources, but I think LeetCode is a well-known kind of term or like brand amongst software developers. So today's going to be a little bit different than the previous episodes because last time I stopped before I actually technically solved this one. Right, so I got all the tests passing, right, as you can see here, but I didn't actually satisfy this requirement, right? With linear runtime complexity, and you use only constant extra space, right? So right now I'm using a map, and that map just gets bigger depending on, the bigger the nums array is, the bigger my map ends up. I actually I was kind of thinking about how to solve this, and I was actually kind of stumped. I kind of cheated before before I started filming, did a little bit of Googling. Turns out I'd actually solved this one in the past. So I actually looked at my previous solution, and I know I didn't come up with this original solution. I must have Googled it. I'm basically going to re-implement the solution, but kind of walk through it, and not necessarily like a proof, but more kind of like explaining it to myself, for myself, I guess. I don't know. So if you don't recognize this operator, that is the JS XOR operator. Oop, what did I do? JS XOR operator. Bitwise XOR operator. And I've never actually used this. Like, I've been working as a software developer since 2015. I've been writing code since 2013. I don't think I've ever actually used this in like an application or on a ticket or anything like that. So I'm going to try and do my best to like explain this for anybody that might not be familiar with this, especially like people that didn't go to school for computer science, right? Like I went to a coding boot camp, and so we didn't actually get into, like, for better or worse, my boot camp didn't cover this. It was also 2014. This was very early in like the coding boot camp industry. Maybe boot camps now are covering this, maybe they're not. My guess would be that most aren't, because it's not directly necessary, I think, for most people to get a dev job. But all right, so let's use this and see if I can kind of explain this solution. So, because I remember when I first saw the solution, like, it seems like painfully simple. Like, it seemed almost like magic. So, all right, so let's go into our code sandbox where we have our tests running in watch mode. Oh, whoops. Oh, what is this? All right, we're good. So let's save here. There we go. Reruns. We don't have any changes. So, right. So I don't have any other changes in the repo. So we can collapse this sidebar. And all right. So let's see if I could do this. So let's see. Let res equals 0. And so this way at least it's returning the proper type. It's just returning the wrong answer. So what we want to do is, so const, I guess, for num of nums. All right, and so this should get us every num, but let's confirm. Yep. Oh, and I will, I'm going to put a log here just to kind of keep track of which test run we're on. Also, I'll need to remember to delete my dot only because I forgot to take that out last time. So that's currently in the main branch of the repo. Whoops. All right, cool. So it's logging the nums. So what we want is, I think we want to, so we just mutate res equals, is it num XOR to res, or is it, what is this? Cannot find name num. Did you mean nums? Oh, I didn't actually declare that. All right, so you can see now it's passing, right? So that's back to, but to kind of explain this, so you need to understand how numbers work and how basically like a base 10 number in JavaScript is written as binary. So let's go ahead and convert these to binaries. So, so let's do a little bit of comprehension refactoring here. So updated res, and then this way we'll keep our tests passing. So I'm just going to start logging these things. I'm actually going to try and do something a little bit different with the way I log stuff. Normally I'll do like, just console.logs, but I was recently playing with console.table, and I'm going to give it a try for debugging, see how that goes. So const rows equals there. All right, const, so rows dot push, and we'll go ahead and let's do this. So let's log what the res is, and then also what the num is and the updated res is. What is this subset about? Cannot update it. Oh, that's because I did something with it before I. All right, and so then let's console.table. Let's do the rows. And right, so you can see here, so initial res is 0, num is 1, updated res, right? But so that doesn't really do much for us. Oh, here we go. So this is the first one. Just for this exercise, I'm going to move this dot only to right there. Oops. Okay. I will clear this and then just rerun everything. Right, so you can see here, so res, so as we start going through here, so res 0, num, updated res becomes 2, 2, num, this becomes 0, 0, 1 becomes 1. But the way that XOR works, right, if we can find the XOR truth table, right? So if A is 0 and B is 0, then A XOR B is 0. If A is 0 and B is 1, then A XOR B is 1, right? If A is 1 and B is 0, it's 1. Right, so as long as they're not the same, we get 0 or 1, right? And so if we actually look at how this works here, right, so we're comparing 0 and 2, so they're not the same, so it's num. So we're comparing 2 and 2, which means it's 0. And so then we're comparing 0 and 1, which means it's 1, right? But it's a little bit like, I think it's helpful to also see these numbers expressed in their binary representation. So let's go ahead and convert some of these to binary strings. So const res as binary string equals res dot toString, and then we're going to pass it 2. Okay, and then I will put that in there, and then we'll say num as toString, const num as binary string equals num toString 2, and we'll log that. And then we'll do the updated res as a binary string. So const updated res as binary string equals updated res dot toString, and then let's add that to our log. What's my dog doing? She's being weird. All right. So let's expand this a little bit. So you can see here, so res, so the binary representation of res is just 0. The binary representation of num is 1, 0, because we have 0 in the 1's place and 1 in the 2's place, and then so we add them up. So 1, oh yeah, so 2 plus 0 equals 2, right? And so the updated res is there. So now this kind of gets carried down to here. So 2, so you can see that they're the same. So 10 to 10, that's 0. This becomes 0. This becomes num. Compare them, right? 0 XOR 1. They're not the same, so we keep 1. One other thing I'm going to do is I'm going to pad these. I guess let me take off the dot only so we can kind of see it happen on everything. All right, so you can see here 10, 1, 10. These ones, because we start using more places of that binary string, are a little bit longer, but you can still kind of see how it works. So 0, So 4 is, we have a 1 in the 4 place, 0 in the 2, 0 in the 1. So 4 plus 0 plus 0. Right, so then this is the updated res. So you can see here, so we take this 100, right, and we compare it to 1. So this would actually be, if we wanted to kind of line these up properly, this would be 0, 0, 1. So let's try and pad these strings to the left. So this way we can kind of compare a little bit better. So first we need, so whatever our res is, so let's get the length of res. So const target length equals dot length, right? And there we go. Actually, I guess we'd want the updated one. And let, actually want the string. Oh, what did I do? Let me undo everything. Okay, const target, oh, need a space. Target length equals dot length. All right, and so now when we want to pad these, I'm going to delete a lot of these variables, but so we can at least see. So I can move those down. And actually, since I'm not, I'll just move these down here and I'll just pad them in line here. So I think it's JS string left pad start. Yep, left pad was the package that like brought down the internet. It's a fun story. If you ever get a chance, maybe I'll try and link to it in the description if I remember. All right, so the way this works is, right, pads the current string with another string multiple times if needed until the resulting string reaches the given length. Padding is applied from the start of the current string. So you can see here in this example. So if we give it string 1, we say pad start, and we say we want to pad it until this string is 2, has a length of 2, and we're going to pad it with zeros. So that's kind of what we're going to do. So pad start. Okay. Dot pad start. Apparently I'm not, let's see here. I guess I need to update to be ES27. And that's not the default config for this code sandbox. Fortunately, I think it will still work. So let's go grab, let's pass this target length here and let's pad this with zeros. Let's do the same thing on the next line. Cool. And let's clear this. Let's save and see what we're looking at. Right, so we're not, so this one's not actually padded yet. Okay, so let's just const padded. Oh, also I misspelled that. Updated res. So padded res as not the best names. So I think this is why they say naming is one of the hardest things in computer science. So dot pad start target length 0. So this maybe shouldn't. Let's see what happens. I broke something, it seems. Number func test. What? Oh, that's because. Oh, that makes sense. So there we go. So now we can see here. Okay, so I guess I didn't use the right length. I guess I want to use the res length, not the. Wasn't that what I would want? Let's see here. So this would be 2. Yep, and send 2, 2. Our padded doesn't seem to be. Looks like I have a bug. Right, so this should be padded there. So updated res is binary string. Okay, seems like I have a bug. So that's correct. That's correct. Maybe let's just try the num as our target length. See how that goes and refresh. Nope, apparently num wasn't the right thing. So let's try res. There we go. Let me. Well, I guess not. Well, that does make sense because, okay. I'm overthinking this. Either way, we can still kind of use these. Maybe not though. 0. Oh, am I logging the wrong thing? All right, I should be able to figure this out. All right, so I guess I should look at the, if I'm starting at 0, I should look at the num. All right, so let's say num.toString dot length. So let's clear that, save this. Okay, so we get here, yep. Because we're logging this res instead of the padded res. So that makes sense, right? So we're getting our updated res. We're getting our num. So this we can do immediately, right? I guess this makes sense, right? Because I'm getting the target length by converting this number to a binary string. Right, this binary string is just a single digit. So this code is actually doing what makes it like it's doing what I told it to do. It just so happens that these numbers were lower. Like if I updated this test data to be like more than 1, which we should be able to try. Like, let's see here. If I just say 5, I think this should be 5. Let's see here and let's save. Right, so here we go. We can see that it's 3 digits now. It was just a single digit before because the number 1 expressed as binary is only 1. All right, let's undo that and get this back to normal. All right, I got distracted by not the best test data. Okay, so now that we can kind of see these side by side, right, so 0, so we're comparing these. So this and this are the same, right? So we get 0. And then this 0, this 1, and we keep the 1, right? So here, right, this is 4 is binary, this is 0. So we have 0 and 4, let's keep the 4. 4 and 1, oh, we can actually, so this is where I thought the solution was very clever, because 4 is contained in 1, but so we can see how this kind of evolves. So we have 100, 1, so this would actually be, right, 1, 0, 1. Right, because this would really be 1, 0. So I guess I need to update this number as binary. I guess what I want to use the res. The goal is to try and compare these, but that's fine. Well, now it should be down to a string. What's the target length of here? So I guess maybe I do want res. Let's try that. See if I'm going to put a dot only on this test. And let's clear and refresh. There we go. So now you can see. Right, so I have 0, 100, 100, 100, and 0, 0, 1. So if we were to stack those over top, so 1 over the 0, we keep the 1. The middle is both 0, so that's going to stay 0. And then 0 and 1, so we end up with 1, 0, 1. Right, so then 1, 0, 1 comes down here. We take 2, that becomes 0, 1, 0. So then we're going to say compare this 1 to this 0, so it's going to be a 1. Right, so we're going to compare this 0 to this 1. So this middle number is going to be a 1. When you compare this 1 to this 0, so it's also going to be a 1. Right, and so this 111 ends up getting us 7 because we have 4 plus 2 plus 1. Right, so then 111 carries down. Our number is 1, so it's 0, 0, 1. So we're going to go from 1, 1, 1 to 1, 1, 0. Because 1 and 0, we keep the 1. 1 and 0, keep the 0, or keep the 1. 1 and 1 turns into a 0. We get 1, 1, 10. Or 1, 1, 0. And so 1, 1, 0 carries down. We take 2, which is expressed as 0, 1, 0. So 1 over 0, we keep the 1. 1 over 1 turns into a 0. 0 over 0 stays in the 0. And so 1, 0, 0 into this becomes 4. So I thought that was a really cool, clever solution. I never would have figured that out, I don't think, if I had never Googled it. So technically, I didn't figure this one out on my own. But I thought it was cool to kind of see. So let's make sure it works in LeetCode, right? So let's so I guess first thing we can do is we can get rid of these console.logs and then we'll commit this change, and then we'll delete the stuff we don't need. Okay, let's do that, save that. Let's get rid of this dot only, make sure everything passes. Okay, and refactor single number to be more performant. Okay, so let's commit that change. So now we can just go drop this whole thing into LeetCode. I think I just got the function body. I don't think I got the, yeah, there we go. So let's run it. Cool, and I guess let's submit it. It's going to be a lot more runtime in memory because I have a lot more stuff going on. But I think once we kind of code golf this, we'll see this. Yeah, because I have so many different pieces going on here, and to try for like the proof. So if we go back to our code sandbox, and so really all we just need is, I don't need rows, which means I don't need those variables, which means I don't need that variable, means I don't need that variable. And really, I don't even need this intermediate variable. So this will just get us back to here. That variable doesn't exist. Save, and now let's go try this one. Run. Okay, and let's submit. I expect to see close to this 84, 40.8 numbers again. Yep, pretty close. Just out of curiosity, I wonder why. So the 84 makes sense. I wonder where this extra 1.2 megs memory comes from. I wonder if that's like the TypeScript annotations. Let's see what something, just like changing some of these variables to like, so let's just change this to, R, and then let's change this to N. All right. I don't think it's going to make a huge difference, but I'll. Okay. Oh wow! It actually took 12 milliseconds off the runtime. Cool. Right, and took 0.3 off the memory. Let's try changing this nums to just. I guess I'm just going to call it X. Let's see what that does. All right, so you see that. I don't think I can get around those type annotations. That's interesting. That was unexpected. What did I do? N of X. Whatever. It's kind of fun to play with those numbers. But so I'm just going to leave this here because this is readable. All right, so let's go ahead and commit this change. So delete unnecessary variables. Yes. Yeah. All right, and let's go ahead and commit this change. All right, and so if we actually go over here to GitHub, to the repo, we go find that. We should see, yep, there it is. Cool, 11 seconds ago. Cool. Well, thank you for watching. I hope that maybe you found that explanation helpful, or I've actually been trying to think of like ways I can use this, or ways that this is like, or situations when this bitwise XOR operator is the right tool for the job. Maybe this will help me remember. I'll let you know in the future, but as of right now, I'm like, it's cool to know how that works. I don't know when I'll get to use it. So. All right, thanks for watching, y'all. Have a good one. Adios.